would have been wonderful at the Spanish Inquisition. Does anybody know what the Spanish Inquisition was? It was this nice little thing the Catholic Church came up with to punish heretics. And if you said my neighbor is a heretic, they would take him away and put him, burn his feet, put him in the Iron Maiden, which has spikes in it, and they stab into you. I would have been wonderful then, because that was pure torture. Guess what I get to do here? Same thing. It's awesome. This is my... Everybody thinks, oh, this is my job. This isn't my job. I love doing this. You could not make me hate this job. Trust me. You could try, but you couldn't do it. I'll tell you this. If you do everything I tell you to do, you'll be fine. If you disregard a lot of what I say, you're going to have a hurtful semester, or summer, as it may be. Okay. We're going to start in section 2. I'll go back to section 1. Section 1 is only about graphing. I might skip it completely and let you do it on your own. There's videos online. It's just plotting points, plugging. It's no big deal. The Cartesian coordinate system. Positive to the right, positive up, negative down, negative to the left, that type of thing, and plotting points. And when we get to graphing, I'll go over that again. But I'll still give you homework in 1-1, just for the fun of it. So I'm going to start in 1-2, which is more in line with what I was doing here. And this is solving linear equations. You're probably thinking, I've done this. This is easy. Yes, you've done this. Yes, you did. What you did was easy. What I'm going to do to you is not so easy. I'm going to start off with it being easy, and then I'm going to progressively make it horrible. So, first thing, steps. If you follow these steps, you will be perfectly safe solving any linear equation. Linear. I'm not talking about any of the other ones, just pure linear. Step number 1. Highly suggest remove all fractions. If you are working with an equation, it is totally legal to get rid of every fraction that you see. Now, there's different ways of doing it, and I'm going to show you a couple ways of thinking about it. And it's really not that hard. It's actually a very simplistic idea. Sometimes the numbers get a little bit bigger, but at least you don't have to have something in the denominator and worry about common denominator and all that mess. Number 2, remove all parentheses. How do you get rid of parentheses? What property? Distributed property. Multiply it all out, expand it. It's another language for it is expand the expression. 3, anytime you remove parentheses with distribution property, and the contradiction here is to combine like terms, you have to use the distributed property again. But you don't think of it that way. You just mush things together so that you get one x on one side and one x on the other side and one number on one side and another number. So combine like terms. The reason that I want you to do this step is I have seen people do this. If you have 2x minus 3 plus x equals 7, some equation like this, and say this was the distribution property and this is what it turned out to be. I have seen people do this. Does that make any sense? Absolutely not. This is the subtraction property of equality, but not over the equality. It's all on the left-hand side. So make sure that after you do the distribution, you combine like terms. Bring things together that come together. That way you don't make any silly mistakes. 4. This is the important part. Put all variables you are solving for on one side. I didn't say the left side, I didn't say the right side, I said put it on one of the sides. I don't care which side. Before you touch anything else, your focus should be on the variable you're solving for. Eventually, I'm going to ask you to solve for an equation that is all variables, and you need to focus on just one of them and treat everybody else like a number. I'm going to call them junk. So, step 5, put all else on opposite side. Oh, by the way, if I misspell a word, don't tell me. I know I can't spell. I'm a mathematician, not a English person. Spelling bees, you ever do a spelling bee in class and you line up and the first person spell a word, you can go sit down, and if you spell it wrong, you go to the back of the line? I was always at the back of the line. It could be the easiest word, the, and I would screw it up. Never learned how to spell. It's amazing I got a college degree at all, right? Thank God for spell check. So, remove the fractions, remove the parentheses, combine like terms, put the variable you're solving for on one side of the equation. I could care less which side. Put all the other junk. I just call it junk. It could be numbers, but it could be other letters, other variables. Move them to the other side. Opposite side. Oops. Side. All right. 6. Create one instance of variable. When I talk about variable, I mean the one we're trying to solve for. You don't always have to do this step, but this is the one where, in case you have ax plus bx, that's 2 instances of the variable. So you'd have to create this a plus b times x, which is just 1 instance of it. So basically, you're going to force the distributive property to make it one variable rather than 2. So this is usually distributive property. The factor version of it. The distributive property. And then the last step, well, you're going to solve. Generally, divide coefficient. Usually it's a coefficient over. The coefficient could be messy. It could be something like a plus b. It could be a weird, ugly coefficient. Usually, if I ask you how to solve an equation, most people say get x by itself. Now, think about that. Where is x by itself in my list? Way down here at the bottom. You've just skipped 6 steps of solving an equation, and that doesn't actually help you get there. If you follow these steps, whether it has fractions or whether it has parentheses, you can skip a few of them, but you do have to combine like terms, put variables on one side, put junk on the other side, and move the coefficient across. Those are the general ones. If you follow these steps, I don't care what kind of linear equation you're given, it could look ugly, weird, strange, something you've never ever seen before. If you follow this one by one, you will get through it. All right. So let me show you simplistic and then make it horrible. And we're going to talk about properties all the way through this. I'm going to show you where the properties crop up every once in a while and why they exist. So, for example, start off simple. 8 minus 3 times x plus 2 is equal to 4 times x minus 3 minus 7. I hope the answer is not 0. Hope the answer is not 0. I sometimes make these up and weird answers pop out of them. So if I do this step by step, remove all fractions. Well, the problem here is there's absolutely no fractions. Skip step number 1. Remove parentheses. Now, one thing I love, can I do 8 minus 3? No. Do you want to? You really want to, don't you? I want to, but you can't. Why? Because this is addition, subtraction, and 3 times this is multiplication, and multiplication comes before subtraction and addition. So you have to be really careful of order of operations. So, distribute. It has to be the whole thing. Negative 3 times x, negative 3 times positive 2. When you're working with integers, it's best to say negative and positive. Don't be doing 2 times 3 and then try to figure out what the sign is. Say negative 2 times positive 3. Negative 2 times negative 3. Try to get used to that language. So, if you don't touch it, copy it down. We didn't touch the 8, just bring it down. It becomes like a typewriter. Change what you change, leave what you leave. Negative 3 times x is negative 3x. Negative 3 times positive 2?
Negative 6.
Negative 6 is equal to 4 times x. We're going to have to distribute over here also.
4x.
4x. 4 times negative 3.
Negative 12.
Negative 12. And don't forget minus 7. Anything you don't touch just kind of falls down. All right. Third step. We got rid of the parentheses. We expanded it. Combined like terms. Well, if I look on the left, what's like?
8 and negative 6.
The 8 and the negative 6. How do I get them together? They're so far apart. It don't matter. Why?
I mean,
What
it's
property?
The same size.
What property? Come on. What allows me to move this negative 6 so it's close to the 8? Commutative. You're changing the order of things, it would be commutative. So anytime you take an expression and you add the first term and the one way over to the right, that's a commutative property multiple times to bring them next to each other. So 8 minus 6 is? 2. I'm going to write this as 2 minus 3x. But to do that, you need the commutative property to get those numbers next to each other. Operations don't work over great distances. They work when they're right next to each other. All right, on this side, I don't have to worry about it. Negative 12, negative 7, negative 19. Same sign, add the numbers, keep the sign, all that fun stuff. All right, so we're down to 3. We combined like terms. Now we're down to an expression that's very common with linear equations. How do I go from here using step number 4? Put all the variables on the same side. What am I solving for? Well, there's only one variable, x. One's on the left, one's on the right. How do I get them on the same side?
You have to do the opposite.
Either A, subtract 4x over to this side, or B, add 3x to that side. Now, how many of you want to subtract 4? Most, because most people are used to moving things from the right to the left. They like that variable on this side. Does it matter? No. Which one do you want me to do? Negative 4? All right, so if I subtract 4x on this side, and I subtract 4x on this side, additive equality property. What is it really called? It's the additive property. Yeah, I think that would work out. The additive property of equality. Whatever you do to the left, you do to the right. Now, why did I do this? What do these two become? What are they called? Inverses. They're additive inverses. When I take these two together and add them together, what does it become? 0. Then I have 0 minus 19. Well, 0 minus 19 is negative 19. What property is that? Identity. So whenever you do this, what do most people call this? What do they call it? Begins with a C. Most people say they cancel, right? They cancel. So anytime you say the word cancel, is it EL or LE? EL. It doesn't look great. Anytime. Huh? Be quiet. Jeez. Anytime you say the word cancel, you are doing an inverse first and then an identity. So anytime you say the word I'm canceling them, you're doing an inverse property and an identity property, one right after the other. Does that make sense? You do this, it becomes 0, that's the inverse property. You take 0 and add it to whatever's next to it, and it leaves it alone, so you get the identity. But most people just say the shortcut, which is cancel. So on this side, it becomes, change color. 2 minus 7x. 2 minus 7x is equal to negative 19, after we cancel. Cancel's not a mathematical language. Can't use it all the time either. All right, so the 5th step, put all the other junk on the other side. What's the other junk? Now, is 19 the junk? No. You have to focus on where your variable is. The junk that is next to it is the term that has nothing to do with x, which is the 2. How do I move the 2? Subtract 2 here, subtract 2 here. This is the inverse identity thing, and we say cancel. And we are left with 7x is equal to negative. Cool. It's actually going to work out nice. I didn't plan on that. And then we're down to create one instance. Well, there is only one instance, so I can skip that step. solve for the variable, divide the coefficient over. Well, the coefficient of x is -7, so divide both sides by -7. I love when people add 7. They think -7 plus 7, that's 0, that goes away. Well, if that's 0, 0 times x is 0, and the variable goes away, so that makes absolutely no sense. So x is equal to 3. That's the properties at work in solving an equation, and these properties are always there. They're always in the background churning away at these things that you have come up with shortcuts. The problem with shortcuts is they don't work in all situations, and you have to be really, really careful when to use them and when not to use them. Use them when it's familiar. Do not use shortcuts when it becomes unfamiliar. Once it becomes unfamiliar, you go step by step and you go back to those properties and figure out what the heck is going on. For instance, to make it harder. Oh, do you think I'd put that on the test?
No.
Heck no, that's way too easy. This is what I would put on a test. Well, before I put it on a test, I have to show you some notation. Notation number 1. History lesson. Long ago. I don't know how long ago. I think it was about 100 years ago. About 100 years ago. Maybe longer. When algebra was first invented, we write things like this. You know, when we want to group something, we'd write x plus 3. And if we want to times it by something like 2x minus 1, this is modern. This is what's called modern mathematical notation. A long time ago, they would write it this way. And they'd use these bars on top as their grouping symbol. So, these mean exactly the same thing. This is the quantity x plus 3 times the quantity 2x minus 1, just like over here to the left. This notation is still around, but people don't recognize it because we don't use it all the time. Where do you still see these bars in mathematical notation? No one knows. You don't see any bars sitting on top of things?
Yeah,
Fractions. You could have something like 4 divided by x minus 3. There's that bar. So what that bar means is whatever's in the bottom is inside of parentheses, our notation. So if you're using a calculator, you have to be really careful. If you type in 4 over 7 squared minus 3, you'll get the wrong answer. But if you type in 4 over divide by parentheses 7 squared minus 3, you'll get the right answer. The calculator understands order of operations, so it'll do the multiplication first and that subtraction second. But if you put parentheses around it, it also understands that. So fraction bars are one of the places where you have to be really careful, and you might want to start putting parentheses around what's in the bottom. Also, what's in the top. I mean, if you have x minus 3 over x plus 3, technically what that means is x minus 3 all divided by x plus 3. It's just that the parentheses get dropped because you go back to the old grouping notation. All right, where else can you see that grouping notation? What other symbolism in math still has it? No one will think of it. It's amazing. But you see it all, well, not all the time, but you saw it earlier. Another place where I put a line on top of numbers.
When you repeat in a decimal.
Not that specific one. Another mathematical symbol that has a line on top. The blank of 4 equals 2. The blank of 9 equals 3. The square root. If you look at a square root, what's on top? That line. So if you see the square root of x plus 7, that really means the square root of the quantity x plus 7. And if you ever type this expression in a calculator, it looks like this. The square root symbol doesn't carry all the way across in a calculator. It just goes sitting in the front, and you have to tell it what's inside of it. So another grouping notation that is left over from the ancient one is square roots. So we got to be really careful of fractions, and we got to be really careful of square roots, especially square roots, how long that line is, because whatever's underneath that line gets put inside. Remember earlier, I wrote something like this. But variables usually go to the right, but I put that one on the left. And the reason I did that is because if you write this, and that line's just a little bit too long, it looks like the square root of 3x, the whole thing, instead of square root of 3 times x. So in that case, I put x's first, so I lose that ambiguity. Second other idea. What we need for what I'm going to do to you is if you have, excuse me, 4 over 5. What does that mean? No, 4/5. But what else does it mean? Well, 4 divided by 5. There's one other idea that you need to know. It is also 1/5 times 4, or 4 times 1/5. You can separate it as a product of two numbers. Any fraction, you can separate it as a product of two numbers. And the reason I want you to know this is if I have 3x minus 7 over 8, I need you to think of it as 1/8 times 3x minus 7. Because they're exactly the same thing. Number 1, the fraction bar becomes parentheses on the 3x minus 7. Number 2, the 8 in the bottom comes out front as a 1/8. Just like the 5 in the bottom over here became 1/5 of 4. Does that make sense? And if you do that shift, what happens is instead of worrying about division, you can worry about multiplication. It's much easier to think multiplication. And also what a lot of people forget is this fraction bar is parentheses, and anything you do out front has to be distributed. And a lot of people just do it to the first one and don't do it to the second one. Or they make some silly mistake with the second one. So it's a lot safer to put that 1/8 out front and then worry about it as multiplication. Alright, reason that I did all that junk is just this one silly problem. Black. Yeah. For example, if I have 2/3 minus 1/4 times, oh no, I don't want to do it that way. Back it up a little bit. Minus 2x minus 3 over 4 is equal to 4x plus 1 over 6 plus 1. Some weird equation. Now this one's going to require the first step, which is get rid of all the fractions. Before you get rid of all the fractions, since multiplication is easier to think of than division, I'm going to float those fractions out front, except for that first one. So I'm going to leave this as 2/3 minus, I'm going to float that 4 out front, but what does it become? 1/4. And it's going to be times the quantity 2x minus 3 equals, float the 6. 1/6 times the quantity 4x plus 1 plus that 1 at the very end. That way you're looking at individual fractions times some other junk. Makes it actually a little bit easier to work with. What we're going to do with this is one neat trick. It's the multiplicative property of equality. I can multiply something on the left. I can multiply this side by 10. But if I multiply the left by 10, I also have to multiply the right by 10. So I get to choose any number I want. What number would you choose? A number to multiply both sides by that get rid of all the fractions. Any guesses?
6.
6 would work kind of, except for the 4.
12.
Now 12 has a special name between 3, 4, and 6. It's the lowest common multiple, LCM. It's also known as the common denominator. So if you multiply both sides by the common denominator, both entire sides, not just pieces of it, 12 and 12. And I'll put a little note here. Common denominator. If I multiply both sides by the common denominator, what it does is it wipes out all the fractions, and you'll just be dealing with whole integer numbers. So let's distribute it through. 12 times 2/3. Now, depending on your way of doing things, there's like several different ways. I had a student last semester that needed to see the 1 underneath the 12. They needed to see that 1 under the 12 so they could line up their fractions top to top, bottom to bottom. The way I think of it is, since it's going to go into it anyways, 3 goes into 12 how many times? 4 times 2 is 8. I find that easier to divide up and multiply across. Or you can go 12 times 2 is 24, 24 divided by 3 is 8. You'll come up with the same answer. By the way, that's the commutative property and associative all mixed together. So this turns out to be 8 minus 12 times a quarter, 3. Do I have to do 12 times 2x minus 3? You're all like, wait a minute. Go back a little bit. Remember I said I had students doing this? And you all went, no, that's not right, right? So if I multiply the 12 times the 1/4 and come up with 3, do I go back and multiply the 12 times the next thing? No, because multiplication says take the answer for the first two, take that answer and multiply it by the next one. Well, the answer is 3, and the next one is 2x minus 3. There's no reason to do it twice. Because you're multiplying 3 things together, and all you're doing is taking the first 2. And then taking that answer and multiplying by the third one. When in doubt to algebra, go back to numbers and test it out. If it doesn't work with numbers, don't do it with algebra. All right, other side. 12 times 1/6 is 2. That absorbs the 12 and the 1/6. They go away and they become 2. What's left over is the 4x plus 1 plus. I love when people put 1.
12.
It better be 12 because you have to distribute the 12 to the 1 also. So the numbers might get a little bit bigger, but at least you don't have to deal with fractions. Now we're back to what we were doing earlier. I'm going to go through this rather quickly. Distribute the -3. This is not minus 3. This is a -3 now. So 8, -6x, plus 9. My favorite mistake is here. I've had people say -9 because they forget negative times a negative is a positive. So be careful with that second distribution. Nobody screws up the first one. They're too close together. 50% of people screw up the second one. If you find yourself with an error, go to that second step and make sure you have your sign right. That's where most errors happen. Equals 8x plus 2 plus 12. That's step number 2. Get rid of parentheses. Step number 3. Yes, I need you to know these by heart. Combine like terms. 8 and 9 by the commutative property become 17 minus 6x is equal to 8x plus 14. Looks almost identical to that last example. Which x do you want to move this time? It doesn't matter. So if I move the 1 on the right, what do? Add 6x to both sides. I eventually don't show this step. What I'll do is I'll show like a little arrow showing which one I moved, and that's all I show. There's a neat little shortcut. I call it the magic mirror theorem. If it's negative on the left-hand side, it's positive on the right-hand side because it's shifted through the equation. This becomes 17 is equal to 14x plus 14. Oh, I forgot. What property allows you to add those two together? Distributive property. Kick out the x, add the 8 and the 6, the x is in there for the 14. What one do I move now? That one? I'm playing devil's advocate. That one. So to subtract 14 from both sides, they cancel, which is inverse and then identity. This is what, 3? Ooh, this is not a nice answer. Equals 14x. And then finally, you divide by the coefficient of the variable you're solving for.
3/14.
And you get x. I always put x first. 3/14. Now, the other one, I had an answer of what, 3? If you have an answer of 3, you could always go back and plug it in and see if the equation balances. Would anybody check 3/14? On my test, don't be looking for integer answers. If you get 3/14, most people's brains go, oh my God, it must be wrong because it's not a whole number. This is not kindergarten. Remember that. Answers can be anything. So if you did your work right, whatever answer you got is the answer. Unless you know you did something wrong, trust yourself just a little bit. Of course, for homework, go back in the back of the book, and if it's wrong, go look at your distribution first and make sure you didn't make any silly mistakes. But for test purposes, you're going to have to trust yourself a little bit. I had one girl in a calculus class one time, horrible problem. It took an entire page. One problem, one page of work. And she crumpled up her paper and threw it away, thinking she did the problem wrong. So I went and retrieved it, right? It looked exactly like my answer key. Step for step. Trust yourself. I did better work guessing on math problems than actually knowing how to do that. Your brain is a wonderful thing. You might not think you're doing it right, but your brain is trying to drag you the right direction. So the best thing is to actually, well, trust yourself a little bit. It's amazing what the brain can conquer. Wow, need water. All right, what could be worse than that? It's bad when I have to pull up my notes to look at. The fractions could look, well, horrid. Doesn't matter. Nope, not at all. Those 7 steps that I gave you will rip this down and get you an answer. You just have to follow them. So, step number 1, get rid of fractions, right? So, there's fractions up here, except the problem is the variable now is in that part of the fraction. Makes it look a little, well, weird. Before I start, let me talk about a few things. Can I let x equal 3? Think about that for a second. What's 3 minus 3? Can I divide by 0? So if I go through all this work and I end up with x equals 3, guess what? X can't equal 3, so guess what kind of answer you get? Absolutely none. No answer whatsoever. It's called DNE. Does not exist. If I go through this whole problem and get an answer of negative 3, I can say DNE because there's no way that this equation is going to balance with negative 3 because you can't divide by 0. So sometimes these things are what's called common sense that nobody has, by the way, but they call it common anyways. So you got to be really careful. At the beginning of the equation, you might want to remind yourself that x cannot be 3 or negative 3. No matter what happens with your work over here, it just can't be those two things. Next thing is I want to get rid of fractions. So I'm going to take both sides of this equation. Notice I use brackets, but you can use parentheses. I use brackets to be really clear what I'm doing. What is the common denominator of this junk? X plus 3, x minus 3. Because this factors into x plus 3 and x minus 3. And if you forgot how to factor, you go to my webpage, you go to Module 1, which is Chapter P, and you look at the factoring videos. I have like 7 of them. Lots of different ways of doing factoring. So I'm going to multiply both sides by x plus 3 and x minus 3. And then this side is also x plus 3 and x minus 3. Yes, I do require you to remember how to factor polynomials. So if you don't remember how to factor all polynomials, please review it. You are responsible for it. Okay, distribution works exactly the same with ugly polynomials. This thing times that thing. Now, if you need the 1 underneath this stuff, that's fine. This is in the bottom, this is in the top, and if I multiply those two together, it is exactly the bottom. So when they hit each other, they go poof, they cancel, that type of idea, and the answer becomes 2. So what was ugly now becomes rather nice. This mess times this thing, way over here. What goes away? Well, anything in common. The x plus 3s are going to cancel, inverse identity themselves away. You're left with an x minus 3 factor and a 1. Well, what's 1 times x minus 3?
X minus 3.
X minus 3. So I would write it minus, well actually, I wouldn't even worry about that. If this was like a 2 or a 5 up here, I would write the number that was up there times the quantity x minus 3. Why? Because if you don't, you're going to forget that the answer here is going to be plus 3 and not minus 3. Because a lot of people will put negative x minus 3. This side, what goes away? X minus 3, and you're left with a factor of 5 and x plus 3. So all the fractions go away, number 1. Number 2, it looks a lot nicer. I mean, that's simplistic. Compared to even over here, that's simplistic. So we can whip out the rest pretty quick. 2 minus 1 is 1.
Let's do
And if you're shaking your head up and down, I'm going to yell at you.
negative 1
You can't do that. So this is 2 minus x plus 3 is equal to 5x plus 15. Combine like terms. 5 minus x. You could write it the other way, negative x plus 5. That's perfectly fine. I'm of the habit of, if there's one minus sign, I try to put it in the middle. I think it's safer there. That side is perfectly fine. Which x do you want to move? Most people would move this one. Add x to both sides. This side becomes 5. This becomes 6x. And that's 15. Come on, we're almost done.
Well, negative 15 on both sides.
Move the 15 over, so you're going to get 6x equals
Negative 10.
negative 10. And x is equal to... Oh, before I...
Negative 10 on 6.
Notice what I've done here. I'm going to skip a step. Me personally, I do weird things from here to here. I was so used to dividing from the left to the right that I sometimes move the 10 over here and write this as 3/5 rather than what it's supposed to be, which is 5/3. I always show my division in my work because that's my common mistake. If you start finding yourself having a common mistake, show your steps. It'll get rid of that weird thinking pattern that your brain gets into. Always reduce your fractions. I take off points for people that leave things like this
It's not simple.
because that is not simplified. I need your answers all to be simplified. Negative 5/3 is the most simple fraction that is equal to negative 10/6. I've had people on a test, seriously, write this. Now, if you're thinking about that for a second, why would they use 6/2? They left 6/2 up here someplace. They were working with a fraction throughout the entire problem when they could have just changed it to 3. And that's the main reason for simplifying fractions. It makes life easier most of the time. All right.